and welcome back to my Blind 75 Python solution series. Today we're going to be taking a closer look at Leetcode question 15, or the three-sum problem. This is a medium level question, and I'll be solving this using the two-pointer technique, which has an O(n squared time and an O(n space. This is actually not the best way to solve this problem. There's actually another way to solve this with O(n log n time using binary search and the Python built-in module collections, but I'm not going to be talking about that second solution in this video. The second solution requires a lot of extra Python knowledge to be able to solve, and the point of this series is I want you to be able to solve the problem without having to know all the ins and outs of Python. But I may make a video of that solution in the future, so let me know in the comments if you'd like me to explain the advanced solution as well. Before we read through the problem, please also take the time now to subscribe to my channel and like this video. It really helps me out and is greatly appreciated. Now that you've done that, let's take a look at the problem. The problem goes as such. Given an integer array nums, return all triplets nums I, nums j, and nums k such that I does not equal j, I does not equal k, and j does not equal k. And nums I plus nums j plus nums k is equal to 0. Notice that the solution set must not contain duplicate triplets. So here's our first example. We have our nums array, and we have this set of numbers right here. And as you can see in our solution, we don't want to have any duplicates, and each of these solutions equals 0. And how we're going to take a look at this problem is we're going to be using, as I said, the two pointers, but it's also going to include actually a third pointer as well. So that's the reason why it's going to be O(n squared time. So O(n squared is not a great time complexity that you want to have. But because we're using three different pointers and we're having to keep track of those, that's the best that we're going to be able to do, at least with that technique.
All right, so let's take a closer look at the problem. So I have the same array from our example above, and up here we have the index values on top, and over here I have our current values, which these are going to be the variables that we're going to be using, and I'm going to be keeping track of when they change because they change quite often. And then this is for when we are actually going to be calculating our current sum. And then down here we have our answer array. Let's take a look at the steps in this problem. So first things first, we just want to create our answer array. Then we're just going to sort the array. And the reason we're going to do that is so that we make sure that we don't contain duplicate triplets in our problem, in our answer. So let's sort the array first. So we're going to delete these values, get rid of all of those, and we're going to go ahead and write this in a sorted way for -1, -1, 0, 1, and 2. And then next we're going to loop through the array until the second to last variable. So we're going to loop till we get here. And our loop is going to use the num variable, which we're going to create. And I'm just going to call that n, and it's going to start right here. Next, if num is greater than 0 and the value of num equals the value of num minus 1, then continue. So right now num is not greater than 0, so we're just going to skip that step. Next, we're going to create our start and end variables, and then start is num plus 1. So num is -4 at 0, so start is just going to be 1 because it's at the index value. And as of now, our values are -4, -1, and then end is going to be at the end of the array, and that's going to be 2. And that's where we're starting. So next, we're going to do our while loop, which is our main while loop nested inside of our for loop. So the step 3 is actually going to be a for loop, and this while loop is going to be nested. So all of this here, right here, up until here, because this is where we return our answer, is nested inside the for loop, which is what causes it to be O(n squared. While start is less than end, calculate the current sum, which is going to be equal to the values of num plus start plus end. So currently, our num plus start plus end is going to be -4, -1, and 2, which is just going to be -3. Next, we're going to check if current sum is less than 0. If so, increment start by 1. So right now, is our current sum less than 0? Yes. So right now we're going to take our start and we're just going to increment it by 1. So we're going to skip the next step, check if current sum is greater than 0. If so, decrement end by 1. It's not. And then we have if values of start plus end plus num equals 0, then append to res. And they don't, so we're just going to skip that as well. So while start is less than end, and the value start equals the value of start plus 1, increment start by 1. So is start less than end? Yes. And the value of start equals the value of start plus 1? No. So we're not going to do that. While start is less than end, and the value of end equals the value of end minus 1, decrement end by 1. Is end equal to the value of end minus 1? Is 2 equal to 1? No. So we're going to skip that step. And then all we're going to do last is we're just going to increment start and decrement end by 1. So start is going to be here, and end is going to be here. And so start is still less than end, so we're going to continue now on our while loop. So our next step, restart from step 3 if start is equal to end, else start is step 6. So right now start is not equal to end, so we're going to restart actually at step 6. So while start is less than end, calculate the current sum, values of num start plus end. So we're going to do that here, and that's what we're going to save at this value. And as of the end of that function, that last one, we're at -4, 0, and 1. And so it's still going to be -3. So this was this first one, -4, 0, and 1 equal to -3. So that's our first loop through. And then, so once again, we're going to check if the current sum is less than 0. And if so, we're going to increment start by 1. So is current sum less than 0? Yes. So we're going to increment our start value by 1. Start is now 1. If the values of start plus end plus num equals 0, then append to res. It's not, so we're going to continue. While start is less than end and the value of start is equal to the value of start plus 1, increment start by 1. It's not. Same thing with step 11, so we're going to skip it. And then we're going to increment start and decrement end by 1. But in this case, our start and end equal each other, so our while loop no longer works up here at step 6. So we're going to restart all the way at step 3 now. And we're going to move n over by 1. N moves over. Start is now at the -1 value. And end goes back to the end of the array. Okay, so we're going to do the same thing all over again. So our num value is going to be -1. Our start value is -1. And our end value is 2. And while start less than end, calculate the current sum. So num plus start plus n equals 0. If current sum less than 0, so increment start by 1, it's not. If current sum greater than 0, it's not. If so, decrement n by 1, it's not. If values of start plus n plus num equals 0, then append to res. So they are. So we're going to append this set to res. Okay, so let's continue on. So while start less than n and the value start equals the value of start plus 1, increment start by 1. Does the value of start equal the value of start plus 1? No. While start less than n and the value of n equals the value of n minus 1, decrement n by 1. So does 2 equal 1? No. So we're just going to continue. And for our last step, increment start and decrement n by 1. So we're going to increment start, end, and we're also going to save those values here. -1, 1, 2, and 0. And then we're going to go back through with our while loop again. So currently, we're at -1 for our num value. Start is 0 and end is 1. And together, -1 plus 0 plus 1 equals 0. So we have another match. So we're going to go down to the step 9. If value of start plus n plus num equals 0, then append to res. Okay, let's go ahead and append it. -1, 0, and 1. So while start less than n and the value start equals the value of start plus 1, increment start by 1. Is start and start plus 1 equal to each other? No. Okay. Same thing with n. Is end and n minus 1 equal to each other? 1 and 0? No. So then we're just going to increment start and decrement n by 1, which would make them cross paths. So now we're going to restart again. And we're also going to write these values down right over here. -1, 0. We're going to restart from our step 3. We're going to move num up by 1, and then we're going to create our start value, which is once again just num plus 1 equals start. So num is -1, start is 0, and n is 1. We're just going to leave those there because that's already inside of our array. It's just if num greater than 0, and the value of num equals the value of num minus 1, then continue. If num greater than 0, it's at the index of 2, and the value of num equals the value of num minus 1. So does num minus 1 equal each other? Yes. Then we're going to skip that num value, and I also have to move this end value back. My mistake. So end is right now going to equal 2 again. So we're going to skip that value, and num is instead going to start
at 0, and start is going to start at 1. So we're at 0, 1, and 2 at the beginning of our next for loop. So same thing, let's begin our while loop again. Start is less than end. Calculate the current sum. 0, 1, and 2, we're going to get 3. And we can actually write that down here. 0, 1, 2, and we get 3. Check the current sum is less than 0. Is the current sum less than 0? No. Check the current sum is greater than 0. It is. So we're going to decrement end, which makes it equal to start, which is where we're going to finish. While start less than end, the value start equals the value start plus 1. Increment start by 1. No. Same thing with 11. We're going to get no. Increment start and decrement by 1. Else otherwise? No. So we are currently at the end of our line. So if start is equal to end, then we're going to start again at step 3. So num moves up the last 1. So num moves up by 1. Start is num plus 1, so start's here. End is also at the end. So start equals end. So we're done, and now we're just going to return our answer. And this right here is our answer.
All right, so we're going to go ahead and create our function for the three-sum problem. And what we're going to do first is we're going to create our results array. And then next, we're going to sort the array, the nums array, in order to avoid duplicate triplets. So we're going to have a couple situations where we're going to do this along the way, but it's just so that we can avoid doing extra work that we don't need to do. Next, we're going to go ahead and loop through our array up to that second to last index. And then we're going to continue to the next iteration of our for loop if there is a duplicate. So we're going to be looking for a duplicate. I'm just going to go ahead and write this out first. Equals nums num minus 1. So if within the num array, if the number that we're currently on, where we're currently at, and the one before is the same, we're going to skip it. So this is just another area we're going to be avoiding duplicate. Next, we're going to create our start and end pointers, and we'll have 3 pointers, num, start, and end. So we got num, n equals num plus 1, so start is going to be 1 in front of our current index value, and then end is going to be at the end of the array. Then we're going to add our while loop, while start less than n, and then we're going to add our cur_sum variable, and this is going to keep track of our current sum. So it's going to be num plus start plus end. And then if cur_sum, so I'm going to go ahead and write that out, if cur_sum less than 0, start plus equal 1. And the reason that we're going to increment start is because we need a larger sum to equal 0. So we know that if by sorting, our start values, the areas that are on the left side, are going to be smaller. So we're going to go ahead and increment that 1 to see if we can get a larger value. Same thing, we're going to do the same thing on the other side. So cur_sum is greater than 0, then end is minus. Then we're going to go ahead and decrement end. And the reason that we're going to decrement end is for the exact same reason we incremented start. It's because we need a smaller number instead of a larger number to equal 0. So we know that a larger number is going to be on the right side since we sorted our array. Else, we're just going to append to res. So if it does equal 0, then we're going to append our values to our results array, because that means that it's equal to 0. And then we're going to check to see if the next number is the same as start. If so, then we're going to increment start so we can avoid duplicates. So while start less than n and nums start equals nums start plus 1. We're going to go ahead and increment start, and then we're going to do the same thing for end. So we're going to check to see if the number before end is the same as the current end. If so, then we're going to decrement end so that we can avoid duplicates. I'll start less than end, and this is just a way that we're kind of checking our edge cases and making sure that we're doing everything in our power to avoid any duplicate triplets. We don't want to do more work than necessary. And then at the end of that, we're going to just increment, start, and decrement end. And then at the very end of this, we're just going to go ahead and return our result array. At our our print statement, and then we run it, we get our values. So that concludes today's tutorial on threesome. If you enjoyed this tutorial, please like and subscribe to my channel. It really helps me out. I'm going to be continuing this Blind 75 series and hopefully finishing it up in the next month or two. Until next time, I hope you have a great rest of your day and happy